Okay, question 1A. If we toss a coin and pick a card, so the two events are completely independent of each other, right? Toss a coin, you can get heads or tail. Picking a card, you have 52 cards to choose from. So we can say that they are independent. B, you toss a coin twice. Same idea, the first coin has outcome heads or tail, and then the second coin also has a outcome of heads and tail. The probability doesn't change, so they are independent. Picking two balls from a bag. So picking two balls from a bag, because they didn't emphasize that there is a replacement, so these are actually dependent events. So the chances of, let's say, getting a black ball in the second selection or the second pick depends on whether or not I got a black ball in the first selection, right? So they are dependent. Now D, because they emphasize that they replace the ball, so now it becomes independent. So as long as you put the ball back in, it doesn't really change the probability in the second pick, right? Getting a raise in pay than buying a stereo. So again, these are dependent. If we are making more money, most likely we will spend more money as well. That's why getting a raise and spending money, they are dependent of each other. Being smart and having blonde hair. So I would say that that's independent, right? If you're smart, being smart and having a different hair color, they are completely independent of each other. Playing hockey and living in Canada. Yeah, I would say they are dependent because Canada has a very high popularity in hockey compared to other countries. So we have more Canadian children who love to play hockey because of our culture. Getting good grades and studying, they are definitely dependent of each other. So, you normally, the more you study, the better grade you get. Okay, so now we are moving on to question 2. A coin is flipped 3 times. What is the probability that the coin lands heads all 3 times? Because these are independent events, so the probability of head will just be probability of head times the probability of head times the probability of head. You get half times half times half. So the final answer is 1/8. If 20% of the student in a math class gets an A, what is the probability that 2 students at random both got an A in math? So probability of getting 2 A's is going to be probability of A times the probability of A. We were told that the probability of getting an A is 20%. So the chances of having 2 students selecting at random who both got an A in math is just 4% or 0.04. If 2 people are selected at random, what is the probability that they were both born in October? So probability of October and October is going to be probability of October times the probability of October, right? These 2 events are also independent. The first person being born in October doesn't change the probability of the second person who is born in October. So first person born in October, the probability is 1/12, because there are 12 months in a year. And same idea that for the second person is also 1/12. So the probability is 1/144. If 2 people are selected at random, what is the probability that they were both born in the same month? So both born in the same month, we can have January and then February, right? March, and then we can go all the way to December. So if you think about January, probability of this both person born in January is going to be 1 out of 12 times 1 out of 12. And all of them is going to be 1 out of 12 times 1 out of 12. So I can simply just times this by 12. Because we have 12 months in a year. So now I can just cross the 12 out, and my final answer is 1 out of 12. And 6. If a coin is tossed and a dice roll, what is the probability of a head on the coin? And a 5 or 6 on the die. So this is just probability of head times the probability of 5 or 6. Probability of head is a half. Probability of 5 or 6 is 6 over 2. So if we multiply them, we get 1 out of 6. If 5% of the population is allergic to nuts, what is the probability that 3 people chosen at random are all allergic to nuts? So I'm just going to say yes, 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 allergic to nuts. This would be probability of yes times the probability of yes times the probability of yes. So probability of being allergic to nuts is just 5%. Now we just multiply them because these events are independent. We should get 0.000125. 1, 2, 3, 4, 5, 6. Yeah. So a very small chance that all 3% is allergic to nuts. Question 8. Pair of dice is rolled 2 times. What is the probability of rolling a 7 both times? This will be probability of getting a 7 times the probability of getting a 7. If you still remember from the table, the probability of getting a 7, the two-way table, should be 6 out of 36, right? If you don't remember, then you can redraw the table. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So again, this is dice number 1 and dice number 2. And then we just add it up. 1 plus 1 is 2, 3, 4, 5, 6, 7. 2 plus 1 is 3, 4, 5, 6, 7, 8. Right, so we have 6 sevens. So this is 6 out of 36 times 6 out of 36. And we should get 1 over 36, because I can simplify this. Divide this by 6 to get 1, divide by 6 to get 6. Divide this by 6 to get 1, divide this by 6 to get 6. So if you multiply them, you should get 1 out of 36. Question 9. A pair of dice is rolled 3 times. What is the probability of rolling a 7 on the first roll, a 4 on the second roll, and a 9 on the third roll? So I can use the same table. This will be probability of 7 times the probability of 4 times the probability of 9. So 7 we already know is 6 out of 36. 4 is 3 out of 36. And 9 is 4 out of 36. And now we simplify. Divide this by 6 to get 1, divide this by 6 to get 6. Divide this by 3 to get 1, divide this by 3 to get 2. Divide 4 by 4 to get 1, divide 36 by 4 to get 9. So our final answer is 1 out of, just using my calculator, 2 times 36 times 9 is 648. Okay, so I'll see you in the next video, and we'll go over the next page of the word problem. See you soon.